recognize clearly. Uh, Good evening, sir.
Good.
My name is Prabhat, and today I will be presenting my pre-thesis research work on development of an optimal approach towards IoT data analysis using clustering techniques. For the past couple of years, I've been doing an intensive research on my topic, and here come today I will be presenting of the progress of what we have done so far, and also how exactly we are going to conclude our entire research work. uh, Moving ahead with the presentations, uh, these are the contents that we are going to present today. First of all, getting started with the introduction, moving ahead with the motivation and the problem context. Then we are going to discuss about the research gaps and the problem statement that we found from the literature reviews. Then the objectives
Context
that we
word
have
to
laid down.
CONTEXT double T ahi ase.
Oh, okay, okay, okay. So T, yes, sir, yes, sir. Content text, yes, sir. Okay, sir. মই correct কৰি লৈছো. এতিয়া correct কৰি দিওঁ নে
নাই নাই পাছত
পাছত?
মই এইটো চাবৰ কাৰণে
Okay,
লৈ
okay,
লৈছো।
okay, 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 sir. ঠিক আছে. Then we'll be discussing about our objectives, followed by the methodology that we're going to follow, that we have followed, and the experimental setup, followed by the results and discussions, and our contributions, conclusion, future works, references, and appendix. Before getting started with the entire research work, I'm going to take you to something which might be very fascinating to all of you, and at the same time, because of which I am or we are pursuing this entire research work. Uh, Towards your right hand side, you see a Coca Cola machine, right? Which is very interesting. And yes, in a PhD work, why do we have a vending machine of Coke, or why do we have this vending machine of Coca Cola? This machine that you see, from the design perspective, you can understand that this is a vintage machine from the 1980s, to be very specific, from the year 1982. Now, the reason why I kept this machine as an introductory part for the entire presentation is because this machine is not a simple machine that we are presenting today. It's a piece of art, it's a state of art on its own, and this remarks or this starts the uh, the era. From this we have started the era of IoT, right? Why am I saying is this? Because back then in 1980s, few university students, they were so lazy enough just to come to the ground floor and to take their coke, and just to get the idea whether the coke is chilled or not, right? In order to understand through the network, what they did is they connected this machine to understand whether what is the current temperature of the coke that is in the vending machine. And moreover, they also got to know like whether the vending machine is running out of stock, or what are the current stock that is there in the vending machine. So basically, this was a very simple problem, a very childish problem, just to understand that whether we have a Coca-Cola inside the vending machine or not, or whether the Coca-Cola is chilled or not. Very simple problem. But back then, it was a very complicated problem. But yes, they solved this problem by connecting this vending machine to the network. And this was the starting where students and researchers from Carnegie Mellon University created world's first IoT. This was in the year 1980s. But back or down the line, in the year 2026, this is what IoT looks like today. You see, we have plethora of devices connecting with each others, each of them solving their own problems, and not only a single problem which got started with the Coca-Cola vending machine. We have those devices now connecting us to monitor health records, to understand the ambient environment details, to understand what exactly is the current scenario uh, that we are living into, right? So all these things are basically controlled or being governed by a technology called IoT, right? Which is the Internet of Things, right? You can see we have a graphical abstract of from multiple sources, where starting from healthcare to transport to industries, to agriculture, right? Uh, or even for smart surveillance, smart homes, right? Everywhere you can see we are gathered or we are surrounded by IoT, right? So based on this, right, we thought of why not to pursue IoT as our primary objective or primary technology for conducting our research, right? So motivating gaining the motivation from this, we also did a little bit of survey where we came to know that not only that it is growing, but it is growing immensely, right? I would like to ponder that why it is growing immensely is because as per the reports from IoT analytics, you can see uh, this was a report in the year 2018 where IoT Analytics predicted that by the year 2025, we're going to have 21.5 billion devices connected globally, which are going to be under the category of IoT devices. And for now, non IoT, we're going to have 12.7, where you see that uh, from during the initial period of the year 2015, the number of IoT devices were very less. The ratio is very less, where 10.1 billion devices were non-IoT devices and 3.8 billion devices were IoT devices. But the entire thing got flipped into such a manner that in the year 2015 we are into a scenario where 21.5 billion devices are IoT devices and 12.7 billion devices are non-IoT devices. This was the prediction in the year 2018. But yes, IoT Analytics, being a prominent market leader in analyzing the market of IoT, right? They have also presented their recent data, where this is the current scenario, where A stands for the actuals, F stands for the forecasted values, where as per the recent records of the Q4 of 2025, right, you can see the current market scenario of IoT is exactly the same to what they have predicted. Like in 2024, right, there was a total number of 18.6 billion active devices with a year-on-year growth of 11.8% on an average, which is pretty huge for a technology which is very new yet very promising. Now, based on these scenarios, like we got motivated to pursue the entire research for the domain IoT, right? But here I said that the devices got increased significantly. So can we come to a conclusion that with the increasing number of devices, we can also say that there is a surge of IoT data? Yes, it's absolutely true that based on the number of devices that grows, right, these devices are also going to generate a lot amount of data, right? So yes, what to do with this data, right? Can we just keep this data and let it dump in a normal storage device, typical in a typical hard disk drive or a typical uh, data warehouse? Or can we take this data further for analyzing the data on getting analytics out of it, or sorry, or getting insights out of it, right? So we thought of why not to take this data and to analyze the data such that through an analytical process we can get some informed decisions, right? So based on this, we did a little bit of survey and we found that there are majorly seven type of analytics that can be performed on this kind of data, starting with the descriptive, diagnostic, predictive, prescriptive, real time, edge analytics, and cognitive, right? So our focus was, since we got to know what exactly the problem statement is, right? Uh, so since we got to know what exactly the motivating factor is, now we were about to find the problem statement. Like based on these points, we wanted to know what is the current scenario or what is the direction where researchers are currently working on, in which analytical direction the researchers are currently working on. So for that, we did a quick literature review. right? It was not so quick that I'm going to present right now. It was an intense research work where we did a lot of surveys. Even we present, even after the survey, we proposed, we like published our paper, based on which we also explained our insights. But yes, back then it was a thorough survey, but right now I will be presenting it in a short and quick manner. Starting with the first paper, right? Uh, it was it was a survey paper where we got to know that the people, they are majorly working on two type of analytics, that's descriptive and predictive. And based on this paper, we also got to know that there are no algorithm proposed, right, uh, which are designed to handle IoT data. And moreover, there are also no real-time data streams, no algorithms which can handle real-time data streams or analyze the latencies, memory usages, and also are designed for scalability evaluation at present. Most of the researchers, what they have done is they have done a prediction, right, which is again a part of predictive analytics, classification, and so on. So we thought of extending it, and we also move ahead with more literature surveys, where out of them, this one we found it to be very interesting because here it was a survey paper once again. But yes, again, from this paper, we got to know that yes, people are now combining 5G enabled technologies with IoT. Right? This was back in 2021 when 5G was very new in the market, right? And again, we got to know that there are 2 points which are again rolling back. That is, there are no algorithms proposed, lack of real-time data streaming algorithms, and majorly no one is discussing about the memory usage and the scalability evaluation at the present, right? So we move ahead, and out of again from the multiple papers, this is one of the paper where we found that okay, this is something which people are discussing about, where people are discussing about uh, predictive analytics, but here they're taking help of an unsupervised technique, right? Where our observation was, right, they're taking help of clustering algorithms, right? And they're discussing about the clustering algorithms where people have used clustering algorithms to do their research work, and the research gap still remains the same, right? There are no online algorithms as such, the real-time algorithms which can handle the IoT data or the streaming IoT data. Coming back to the next paper, where we have also seen like people are also dealing with digital twins and IoT, where again this entire thing was completely rule based, like a standard equation kind of thing, where you give the input, right, it processes and it produces the output, right? But we wanted something which should fall into the category of adaptive learning, where based on the data and based on the patterns, it should evolve on its own, right? And we all know that no, nothing can be better than machine learning on its own, because this is something where this technologies, based on this technologies, we can get the insights, and we can use mathematical components to get an adaptive learning scenario, right? So we again moved ahead with one more paper, right? Yes, once again, yeah, there were a lot of papers, but yes, we are just presenting a summary of the papers, because here we cannot present all the literature reviews that we have done. But in this paper, what they have done is they have used the IoT and clustering from networking perspective to improve lifetime information security, not data level anomaly detection. Again, there were no real time analytics, and majorly there were dynamic adaptability scenarios that were explored. Now, coming to one more paper, what we have already studied, right? In this paper, what they have done is again they have developed an improved clustering algorithm, which was pretty good enough. But the issue with this entire algorithm was that, again, this was something which was real time, and the data set was available beforehand, right? So this were the papers that we have done, and this is the paper which made us awestruck, because they say that they were discussing about the real time analytics, right? So we thought of, fine, okay, if they're discussing about real time analytics, then there must be something where they are discussing about dealing how to deal with real time IoT data. But again, here they were discussing about a window based non adaptive k-means clustering algorithm. It means, let's say, for 30 seconds of period of time, they're going to capture a chunk of data and then they are going to feed that data to the clustering algorithm. Not a streaming data. Like if data comes, directly feed it to the clustering algorithm. Again, if data comes, you feed it to the clustering algorithm. It is not like that. Based on timestamp, window stamp protocol, they are picking up the data and they are just putting the data into the clustering algorithm based on the window time frame or the buffer time where they have collected the data. So this was not a true real time uh, true real time clustering algorithm or true real time analytics as named. So yes, based on all these papers that we have surveyed, and the prominent ones which we have displayed, right, we came to the conclusion of getting our research gaps. So the gap was in the following points. The gaps are presented in the following points. Number one, scalability gap, right? There were no algorithm as such, or there were no technique as such, where very large IoT streams could be handled in a real time true sense. Adaptability gap, right? As soon as the pattern changes, there was no such model which could adapt to the pattern. Latency gap, yes, very slow. Existing techniques were very slow to make real time decisions. Security gap, based on the clustering techniques, there were no study as such where they were detecting anomalies on real time or cyber attacks on real time. Then again, uh, interpretability gap, right? There were no algorithms where um they could explain or interpret the results of the clusters which were getting generated. And yes, one of the most significant thing, that was the integration gap, where there were poor integration between devices such as edge devices, fog, and cloud computing devices. And last but not the least, right, that was the evaluation gap. Like there were no standard protocol or standard technique based on which those clustering algorithms could be evaluated. Like how good they performed, how well they performed, whether they're flexible on various domains or not, right? So these things were missing in the entire existing research scenarios that we have found. So based on all these components, we developed our problem statement that we have developed to design dynamic clustering technique capable of handling large structured and unstructured IoT data in real time with minimum time complexity and automatic clustering enabling informed decision making. So we wanted a real-time clustering algorithm which could handle both structured and unstructured data with minimum time complexity, and at the same time there should be a facility where we could detect the number of clusters automatically, where based on the number of clusters we could also detect the anomalies, and based on which we can make our informed decisions. So based on the problem statement, we fostered four research objectives. The first one, to develop an improved clustering algorithm with less time complexity and which can also determine the number of clusters more efficiently and accurately for a large volume of data. To analyze the clusters using the improved clustering algorithm and to find hidden patterns for both structured and unstructured IoT datasets. To form clusters of similar IoT devices to reduce the latency in IoT data transmission, to detect vulnerabilities in clusters of similar IoT devices formed within the processed clustering based approach. So let's get started with the methodology. We have divided our entire research into a few phases. majorly from phase 1 to 6. So in the phase 1, what we did is we tried to perform a survey on the existing algorithms that were already there, and we wanted to understand which particular algorithm was better for IoT data, because previous to this there were no research as such where they were analyzing this algorithms for IoT data. So we did a intensive survey, or we would like to say intensive uh, computation, where we were analyzing this particular algorithms on IoT data, starting from uh, a batch of, I'd like to say, starting from a data set of size of, let's say, 10,000 to 1 lakh, right? So incrementally we were just increasing the number of size of data values till it reached 1 lakh, and we were just trying to see which algorithm performed in which perspective and how well they performed, right? But through the entire study, there were algorithms which, such as k-means, fuzzy sequence, bisecting k-means, which were pretty good. But out of all these algorithms, we got our birch, because algorithm which not only performed no algorithm was even good to handle large volume of IoT datasets. So we thought of, let us take this algorithm and let us try to do some sort of modifications such that this algorithm can also handle real time IoT data. So yes, this was the phase 1. In the phase 2, what we did is we deployed our sensors along with the edge devices into various locations. Those were ESP32, which with DHT11 temperature and humidity sensors. As in all, total 6 sensors and 6 devices were deployed. Those edge computing devices into various locations, and those devices were responsible to send the data into a localhost server. From the localhost server, those data would get propagated to MongoDB, as well as parallelly it would get propagated to the Oracle virtual machine instance for computation. And there was this web interface where we could display our results in real time manner, right? And also, yes, I missed one thing, that from the local server, this data was also getting propagated to an open source platform, that's ThinkSpeak Cloud, where from where we could also show the matrices in the form of Gauge. So basically, as in all, total 4 layers were there, from the data collection layer to data ingestion and storage layer to data processing and web interface layer. This is the snapshot of the the virtual machine where we have done our computation. It had 32 cores and 2 CPU was Intel Xeon. And in phase 3, since if you remember, like our objective was also to analyze this particular algorithm on unstructured data. So in phase 3, we have also deployed multiple Raspberry Pis along with camera sensors in various locations, where again the data would get propagated to localhost and MongoDB. From there, again it would get propagated to a processing layer where our real-time birch was deployed, and next to it, again we were displaying the inference in a web interface. This is the scenario. This was the scenario of the various devices that were deployed, the address and the MAC address. And also these are the geotag photos that were taken while deploying the device in the various locations.
আমি কেতিয়াৰ
Next to
পৰা
it,
ষ্টাৰ্ট কৰিলো প্ৰভাত সেইটো ক'ব
I'm also
লাগিব।
presenting.
হেল্ল',
Okay.
মানে
Okay,
কেতিয়াৰ পৰা
okay,
আমি
okay, sir.
when we have
2024.
started no 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 সেইটো নহয়, when we have started collecting the data means সেইটো অকমান ক'ব লাগিব বস্তুটো।
Okay, sir.
বুজি পাইছা?
Okay. Couldn't get to since. Mm-hmm. Since 2022,
We
we are
have
collecting
done
the
this
data.
part, review part, we have
Mhm.
analyzed that, and we have found this gap, এনেকে প্ৰতিটো এটা অকমান অকমান টেনিয়ৰ সেইটো হৈ গ'ল। আৰু
Okay, okay,
আমাৰ
okay. ঠিক আছে, ঠিক আছে।
মানে কি বিচাৰে তাহাঁতি যে ইমানখিনি যে প্ৰগ্ৰেছ হ'ল, অ'কে, চ'
হুম, হুম,
6 month ৱাইজ প্ৰগ্ৰেছত আমি কেনেকে কেনেকে প্ৰচিড কৰিলো সেইটো ক'ব লাগিব। বা এট দি এণ্ডো তুমি ক'ব পাৰা যে ইমানখিনি কামৰ ইমানটো পৰ্চন এইটো কৰিলো, এইটো টেনিয়ৰত কৰিলো, সেনেকে সেনেকে বুজাই গ'লে হৈ যাব।
অ'কে, 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 অ'কে। এনে ছাৰ চাইডত কি মই ইয়াৰটো লিখি দিম নেকি, মানে এইটো
না, ইয়াৰ
কোনটো
লিখি
ইয়াৰৰ ওপৰত?
নিদিলেও ইটছ নট এ প্ৰব্লেম, বাট পাছত যদি পাৰা কৈ দিবা, মানে কৈ দিলে কি হয়,
অ'কে, 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 অ'কে,
দে উইল বি
অ'কে ছাৰ।
ছেটিছফাইড that the work is in the continuous mode and he has done this part in here, this part in there, like that, মানে সেনেকে বস্তুটো হেৰি হৈ যাব, কণ্টিনিউটিটো আহি যাব। বাকী বঢ়িয়া গৈ
অ'কে,
আছে,
অ'কে,
প্ৰেজেন্টেশ্যন ঠিকেই গৈ আছে, কণ্টিনিউ কৰা।
অ'কে, 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 অ'কে ছাৰ, অ'কে ছাৰ, মই এইটো নোট কৰি ল'লোঁ ছাৰ।
ঠিক
মই
আছে।
তেনেকৈ ক'ম তেতিয়াহ'লে। ঠিক আছে। Okay, so yes, we have deployed these devices, and we started the collection of data back in the year 2022, and from there on we started collecting the data for both for the structured like the structured values, and for unstructured values we started in 2023, in the late 2023, where we deployed multiple Raspberry Pis with the camera sensors, where they were deployed to capture random images after a specific interval of time, right? And next to this, I'm just showing the graphical or the geographical interface of the various points or the various locations where those devices were deployed, starting from our Raspberry Pis to our ESP32s along with the DHT11 sensors. And yes, in the phase 4, right after the collection of data, we went through data pre-processing, specifically for the unstructured images, because those unstructured images or these images are required to be pre-processed to extract the features, and we have chosen the VGG16 model to extract the features, because yes, without extracting those features we won't be able to fed them into the clustering algorithms, because yes, again, this images contains matrix of values, and those matrix of values needs to be extracted. And right next to it, we yes, we did a controlled experimental setup, where we kept on running these experiments into multiple number of times, increasing the data set size, just to check the consistency and the stability of the algorithm that we have designed. And for evaluation, as we can see that we have used Silhouette technique and Devious Baldwin and Kalinsky to measure whether the number of clusters that were performed were pretty good enough to be considered or not. And in the phase 5, this is a graphical abstract where I can make you understand what exactly we did. Like, so it to phase 5 yeah, that mistake हो गई।
It's 5, right?
Phase 3 हुआ है। In the phase 5 we did check the uh, algorithm that we have designed is capable of analyzing security threats or not. Initially we launched a DDoS attack in a, yes, obviously in a uh, in a specific range of IoT devices that we have deployed, right? In those, all those attacks were controlled, right? So on those controlled scenario, we launched our DDoS attack, where through simulators we tried to attack those ESP32 devices. Then next to it, as soon as those devices got choked, right, we also tried to launch deauthentication attacks, such that those attacks or those devices can deauthenticate, get disconnected from the access points by sending deauth frames, right, fake deauthentication frames, data frames. And right next to it, we launched an evil twin attack. So let me explain a little bit about what exactly the evil twin attacks are. So right after deauthentication attack, these evil twin attacks are very interesting. So as soon as the ESP32 devices got disconnected from the access points, the moment we launched deauthentication attacks, to spoof the entire scenario, to fake the entire scenario, we created fake access points by the same name, based on which those ESP32s were connected. So ESP32 devices are such devices which are dependent on SSIDs. So yeah,
based on the fake access points, those ESP32 devices which were disconnected from the actual access point thought that this access point by the same name are to be the original one, and they got connected to the fake access point. The moment they got connected to the fake access point, this is the point where we could launch ARP, or man in the middle attack, right? By sending address resolution protocols, and also to read the data in between, and to change the values, and to send the manipulated values to the database. For example, a temperature sensor T1 is reading a data, let's say 30 degrees Celsius. Right after the MITM, we could change it to 40 degrees Celsius or 200 degrees Celsius, right? And in the database, the value that was going ingested was 200 degrees Celsius. So there was a series of attacks that we launched just to understand, like, if we are able to launch the attacks or not. And based on this particular scenarios, we deployed our clustering algorithm to check, based on the pattern, like the data frames, or uh, the data packets that were getting captured, right? Can we cluster them, and can we say that these are the malicious ones and these are the non-malicious ones? And in the last phase, what we did is, once again, the phase 5, yeah, what we did is, here we created the entire flow of the application that we have designed, starting from the login authentication, to selecting the device, seeing the status, doing the real-time analytics of all the devices that were deployed. And in the last phase, what we did is, we did a benchmark test across multiple datasets, or the benchmark datasets that are available, like the real-time IoT 2022, Air IoT, CIC, IoT IDAD datasets. And also we did a comparative analysis with all the streaming clustering techniques that were already existed, like ClueStream, Clustry, and DBStream. And yes, in generalization, just to check whether the algorithm that we have decided, or that we have developed, was good enough to uh, to to be used in non IoT scenarios as well or not. So this was the entire methodology. Based on this methodology, we want to come to the next part. Sir, ইয়াত এইটো slide
আচ্ছা,
এতিয়ালৈকে
ইমিনিটৰ
বনাই আছো।
পাছত এইটো লিংক কাট খাই যাব, প্ৰভাত। উই হেভ
অ'কে অ'কে ছাৰ।
4 minutes।
ছাৰ, ছাৰ, আৰু এটা
কুইকলি
কথা ছাৰ,
চামাৰাইজ
এতিয়া মই
কৰা।
জাষ্ট, মই অকল দুটা শ্লাইডে ছাৰ ক'ব পাৰিম, কেলেকি এতিয়ালৈকে জাষ্ট মই কমপ্লিট হোৱা নাই, অকল দুটা মান
হুম,
বাকী আছে, এইটো কৈ দিছোঁ মই ছাৰ পটককৈ।
অ,
So, before getting started with the algorithm that we have designed, let me tell you what exactly the Birch algorithm is, because we have selected Birch as one of the most best performing algorithm based on our survey that we have conducted, and based on our computation, we found Birch as one of the best. So, what exactly Birch is all about? So, Birch, what it does is, it takes the dataset X, which contains multiple values, data points specifically, decides the threshold, and then starts computing the cluster feature, right? And builds the cluster tree, and checks the radius. If the particular value, if the radius that is being calculated is below the threshold, absorb or send it to the new cluster. So now, to make you understand better, let me show you the mathematical equations or mathematical models based on which you will be able to understand how exactly this entire scenario works. So you see, cluster feature is a triple. It basically composes of three major components, and for the number of data points, L is linear sum, S is the squared sum. Equation 2, as you can see in the below, represents how exactly LS is calculated. It's a very simple way. You just find the linear sum of all the data points that gets ingested. For example, 2, 3, 4 are the data points that gets ingested. Then linear sum will be 2 plus 3 plus 4. As simple as that. Squared sum, 2 square plus 3 square plus 4 square. As simple as that. Just add it up, you get the square sum. And the centroid, or the mu, is basically the ratio of ls by n, linear sum by the number of data points that we have. And radius is the square root of squared sum by n minus linear sum by n whole square. And at last, what you do is, you check whether the radius that you have calculated is less than the threshold or not. Here, this point that you are able to see, that is x minus mu, is less than threshold, is less than threshold or not is the initial check that we perform, and is the most common technique that is being performed by most of the clustering techniques. But this is what this radius is what makes the Birch clustering algorithm stand apart from the existing techniques, because it does the check two times: initially while while performing the computation of the CF, and at last after calculating the CF, it checks the radius whether the radius satisfy the conditions of uh, the threshold or not. If it doesn't satisfy, then just move the data point to a new cluster. Now, based on this, what exactly our algorithm is doing new? What our algorithm is doing new is we are capturing the data and dividing the data into multiple chunks, such that each chunk can be taken care by multiple threads. So we introduce multi-threading, where each chunk of data is being sent to a thread, and that particular thread is responsible to calculate the cluster feature, and at last we perform a global summation of all the cluster features, such that those kind of groups can be merged all together. Sir, এইটো ইমান লোকে বনাইছোঁ এই টিপিকেল মডেলটো বনাই পিনে তাৰপিছত মই আৰু মানে ৰিজাল্ট এনালিচিছবোৰ প্ৰেজেণ্ট কৰিব পাৰিম।
চেপ্টাৰ ৱাইজ বস্তুখিনি দি দিবা। আৰু হেল্ল' শুনি পাইছা? চেপ্টাৰ ৱাইজ দি দিবা। আৰু তোমাৰ
ছাৰ শুনা পাইছোঁ ছাৰ, আপুনি দেখা পাইছে ছাৰ মোক?
মই এইটো কৈছো অবজেক্টিভখিনি এটা মেপিং
হয়
কৰি
ছাৰ।
দিবা। মানে এই পাৰ্টিকুলাৰ অবজেক্টিভটো আমি এনেকে ফিল আপ কৰিলো এখন পেপাৰ, ৰাইট? আৰু পেপাৰবিলাকত তোমাৰ নামটোৱে ৰাখিবা।
Okay, sir.
No need to mention
Okay,
about
okay,
other
okay, sir.
authors' name.
Etol ke di dim, sir.
So ETL di diba.